All right, so we're dealing with transformers and large language models, right? They're probably a little bit too large to run on your desktop. It might be okay though, but just to be safe, I'm going to run this on Google CoLab instead, in the cloud as it were. So if you haven't already been there, go to colab.research.google.com. You can see I'm using a pro subscription here, but a free one should do, apart from actually doing the training that I'm going to show you. And you can skip that part. It's not a big deal. Just watch me do it. It's going to be a lot easier anyway. So go ahead with your free CoLab subscription there. And what I want you to do is go to File, Upload Notebook, or there might just be an Upload button when you go here. Hit that if so. And let's navigate to your course materials. For me, that's under ML Course. And go into the Gen AI folder. And you should see a Transformers ML Course IPYNB file. So let's go ahead and upload that into CoLab. And here we have it. Cool. All right, so let's play around with Transformers a little bit. So we're going to import the Transformers package from HuggingFace. And we haven't talked about HuggingFace much yet, but just to give you a quick look at what it's all about. It's huggingface.co, by the way, not com. And this is basically a giant repository of pre-trained models. Some of them being very large transformer models, large language models and whatnot. You can see here that the Meta's Llama is posted here. Stable Diffusion is here if you want to use that too. They're all here for you to use for free. Or you can use GPT-2 or GPT-J. OpenAI, it turns out, isn't all that open, so you're not going to get GPT 3.5 or GPT-4 through here, but there are some pretty powerful models here nonetheless. Llama, for example, being a pretty good one. And yeah, it's unless you want to pay for storage and actually store your trained models here yourself, you can do a lot here for nothing. So it's a really impressive service. It's also a good educational resource too. So let's say you did want to use the Llama model from Meta. This is a text generation model built on PyTorch and developed by Facebook, right? Or Meta more specifically. And this card gives you some more information about it. You can also learn more about how to use it. So like if you go to Docs, you'll also find a lot of important training materials here on how to use Hugging Face in general. So if you want to learn more about Transformers and go into more depth there, you can. There's also some really great tutorials here. So if you want to learn even more or learn it from somebody else, that's cool. I won't be offended. There's actually some good documents here and also some good video resources here as well that show you how to go about using Transformers on Hugging Face. And not only is it just a repository, it's also a collection of useful coding tools and packages. So like we're going to see, you can download a tokenizer package that will tokenize stuff for you. You can download pieces of the Transformer and sort of use it on your own and explore how it works. So great resource to have. Hugging Face is kind of taking over the machine learning world in terms of being the go-to place for getting these pre-trained models because, well, training them yourself is prohibitive given the size that we're at these days. So I'm going to start by installing Transformers from GitHub, from source. And I'm doing that because later on I want to actually fine-tune one of these models and make it into my own thing. And to do that, you need to be working off of the built from source version. So let's let pip go off and do its thing to install Transformers from Hugging Face, just the package itself for Python. That will take a minute or two, so I'm going to just come back when that's done. Oh, and do make sure that you have a GPU instance requested here. So if you go up here, you can change your runtime type. Make sure that you have a GPU of some sort selected. I'm using a V100. You may have different choices if you're using a free account, but if you can get a GPU, that will definitely help matters. So do select that before you get going. All right, that initial installation of the Transformers package succeeded. Let's go on and install a few more things. What we're going to do is install Jupyter Lab, IPyWidgets, a package called BERTviz, and the Xformers Evaluate and Matplotlib packages that we're going to need throughout this notebook. So our objective here is to visualize what's happening at the attention level. And to do that, we're going to use BERTviz, which in turn depends on all this other stuff. So BERT is a transformer model that is built entirely on encoders as opposed to GPT, which is built entirely on decoders. But the part we're going to look at first, where we're just going to be tokenizing stuff, doing positional encoding, and doing self-attention, that's the same throughout all these different models. So whether it's BERT, whether it's GPT, or something else, what we're about to do will be relevant no matter what. So let's go ahead and install those packages as well. Just Shift-Enter in there. And again, that will also take a couple of minutes, so I will pause and come back when that's done. All right, that all went swimmingly. Oh no, it didn't. It is warning us that even though it installed this stuff, I do require a restart to use it. So, okay, fine, I'll hit the handy dandy restart runtime button. And presumably that did what it needed to do. So let's move on. Let's talk about tokenizers. So from the transformers package, graciously provided by HuggingFace, we're going to import BERT model and BERT tokenizer. Again, BERT is just a specific kind of transformer that is based on encoders entirely. But again, that doesn't matter because for tokenization and positional encoding and self-attention, it's all the same. I'm just going with BERT because it has a really nice visualization tool that I'm about to use. So let's talk about tokenizers. Let's go ahead and load up the BERT base uncased model, just meaning that it's not case sensitive, so everything will be translated to lowercase. I'm going to load up that pre-trained model from HuggingFace with that one line of code. And that's what it just did. It downloaded all the pre-trained weights and biases for that huge BERT transformer model from HuggingFace. So now I can just use it. Now I have a model that's based on that pre-trained model, and now I can use that model to make predictions or do other stuff, right? So that's handy. All right, so our tokenizer, however, is just based on that actual BERT tokenizer. So we have the tokenizer component, and then we have the model component. Right now, I'm just going to use the tokenizer component because I want to illustrate how tokenization works. So let's pass to the tokenizer a string, the sentence, "I read a good novel," and let's print out how that translates that string into numbers. So again, neural networks can't deal with words. It has to deal with numerical values at the end of the day. And the first step of using any transformer or any neural network for that matter is to translate your words, if you're dealing with natural language processing, into numerical representations of those words. That's what tokenization is. So you can see here that the sentence, "I read a good novel," ended up getting translated into the numbers 101, 1045, 3191, so on and so forth. You can also see that we have an attention mask generated automatically as well. As we'll talk about later on, that's important for making sure that we're only processing the part of that sentence that we should be at any given time. So that's interesting, right? I read a good novel. That's 5 words, but somehow we ended up with more than 5 tokens. So what's really going on there? Well, first of all, it's not necessarily the case that one word equals 1 token. Sometimes you might have a word that is composed of multiple tokens, right? So that could be what's going on, but it turns out there's more to it than that. Let's go ahead and take that list of tokens that we got back and translate it back into words. So that's what tokenizer.convert IDs to tokens does. It takes a list of tokens and converts them back to their readable values. And you can see here, what we're getting here is a special token called CLS, which means that we're just starting to say something. It then translated, "I read a good novel." Each one of those words did in fact correspond to a single token. And you can see that because we're using the uncased model, those are all being given back to us in lowercase. Also, the period at the end of the sentence, that is its own token, its own individual token as well. And finally, there's another special token indicating that that is, in fact, the end of this string. You have to tell these models when they're done explicitly, right? So during training, you have to say, hey, I'm done here. There's nothing more to look at. Otherwise, it will just keep on looking at the rest of those inputs going into the transformer model, even though it may be nonsense. And similarly, when we're generating text by using this model to complete text, or do a chat or whatever it might be, that model needs to know when to stop generating output as well. So when the model says, I'm going to hit this SEP character because I think I've reached the logical end of a thought or a sentence, it will know then to stop saying stuff. Otherwise, it would just keep on going and start generating nonsense. So that's tokenization in a nutshell, and you can see how that works here. We're going to look at some more specific examples in a bit, but yeah, it's pretty straightforward stuff. All it does is have a mechanism for converting words into numbers and then converting those numbers back to words. That's it. That's tokenization.